In this video, we'll be demonstrating how to implement a factorial ANOVA in the R software. I'm going to start by using the dataset tooth growth, and if you're not familiar with this, you can quickly investigate. It's about the length of teeth of gerbils given certain dietary supplements and dosages of those dietary supplements. Our goal is to see if the dosage and the supplement impact the length of teeth or the tooth growth. Now we start, as always, by creating our model. So I'm looking at the length of teeth as my outcome and the supplement, and then I'm going to use as.factor to make sure that my dose is listed in as a factor. Now first I should note that if I just ran this particular model, this model looks at the dosage factor and the supplement factor, but doesn't necessarily look at interaction. In R, an interaction term specifically is listed via the colon operator, so if I wanted to look specifically at just the interaction, I would use the colon. But if I want to look at the main effects and interaction, I could write supplement plus dose plus supplement colon dose, or I could just use supplement star dose, which R interprets as you asking to include the main effects, supplement and dose, as well as the interaction effect. Now recall, the very first thing that I do in these types of models is to look at my assumptions. So I'm going to just do a real quick check of assumptions to see if anything is super outstanding. My homogeneity of variance looks just fine. My normality plot looks just fine. So in this case, we're ready to go forward with our analysis. If we had an issue, we'd write it up. And of course, in the real world, we'd look for a better model to use or try to implement a transformation that fixes the problem. In class, what we would do is you could try a transformation if you wanted to or thought it would look good, but make sure you don't just stop and say we can't go on in an in-class analysis. So now that we've done that, we can go on to interpretation. Now don't be confused here. It looks like we've got an extremely significant supplement effect and a extremely significant dose effect, but again, don't be confused, because remember, when we're analyzing factorial ANOVA, that includes an interaction effect. The very first interpretation that we use is for the interaction effect. So looking at this interaction effect, we find that it's statistically significant. So we stop. We do not interpret main effects, and we go straight to the interaction plot to interpret the interaction of the different factors. In R, there's a built-in function called interaction plot. Now, reading its documentation quickly, we can see that the first thing that it's looking for is the x factor. That is, which factor do you want on the x-axis? Then it asks which factor do you want on the to trace the different lines, and then it asks what is the response. So we're just going to go on and give it these different factors. On the x-axis, I'm going to put, why don't I go on and put dosage. On the y-axis, I'm going to put supplement, or excuse me, to trace, I'm going to put supplement. And then the y-axis is going to be the length. So if you're not seeing this, again, think the x-axis, we have the dosage here. The trace is going to be the different dietary supplements. And then the y-axis is going to be the length of the teeth. So what we can see going on here is that there does appear to be something going on. That is, the change from dosage 1 to dosage 2, though it increases with the VC supplement, it stays pretty flat with the OJ supplement. Note that this interaction isn't particularly impactful on our decision making, though it is important to always check it out when we have a statistically significant interaction. In this particular case, because the scale of the interaction is so much smaller than the scale of the dosage factor, interpreting dosage might have been fine. But we can interpret from this interaction plot too. So whenever we have this statistically significant interaction, that's a good hint to not just take these main effects at face value. Again, they could be fine, they could not be fine. In this case, they would have been, but it's better to go to the plot to interpret. So looking at the interpretation of my effects, And again, I could, in the presence of a statistically significant interaction, I can still interpret my main effects. I just have to do it within the context of the plot. So within some of those sharp contrasts that we've seen, or those huge interaction effects, there is no interpretation of main effects, because the interpretation of the main effects is so dependent on the level of the other factor. In this particular case, it doesn't really matter which supplement you're using. It definitely looks like as we go from half a dose to full dose, we're improving the length, and as we go from a full dose to a double dose, we're improving the length. One thing that I do note is that the improvement from moving to a full dose to double dose that's seen in VC is not as much, or excuse me, is not the same size as is seen in OJ. The double dosage for OJ does seem to increase. So again, there is an increase as we move from the single dose to the double dose in both factors. It's just that the increase is smaller in the OJ supplement than it is in the VC supplement. Now, looking at which is better, the VC or the OJ supplement, that too doesn't seem to matter depending on the dose in the half dose and the full dose, but at a double dose, they're about the same. So how we might interpret this is that OJ seems to be a better supplement for the growth in teeth of gerbils if we were just giving a half dose of OJ or a full dose of OJ. But at a double dose of OJ and VC, it looks like they give about the same amount of growth. So looking at this, we might recommend the OJ supplement if you were giving half a dose or full dose, but we might say that OJ and VC do about the same job at a double dose. Note when this could be useful. Let's say VC was a much less expensive drug, but the length of teeth in gerbils was an extremely important thing that you wanted to make sure that you were taking into account. So in that particular case, what you would look at here is you would note that while my OJ might be worth the money in a half dose and a full dose, in the case of a double dose, because VC is cheaper, it might be worth using VC here because, again, OJ and VC seem to have about the same. Now, if I'd have just looked at the dose factor, or if I'd have just looked at the supplement factor, on average, OJ is going to look higher than VC if I was just looking at the averages of the supplements. So this interaction plot allows us to really interpret what's happening with the supplement's effect on tooth growth while accounting for dosage. So again, this interpretation of at a double dose, these are the same. That is how effective is the supplement in the tooth growth after accounting for a second factor, the very definition of an interaction effect. So this interaction plot really is necessary to interpret this data appropriately. This has been how to run, check assumptions for, and look at the interaction plots of a factorial ANOVA in R.